Hello engineering students, Mr. O again. I'm going to do a second example, or this is example number 4, but I'm going to do a second example on a method of joints. So previously we just did an example. The previous video was where we knew the force of, let's say for example 4n, and we were asked to solve these two, the vertical and the horizontal of this truss, of the edge of the truss. So method of joints obviously is really used for understanding truss type calculations. But what happens now if we do not have that force and we ask to solve this two? Now instead we have this force. So method of joints says we need to look at that joint and work out all the horizontal forces and all the vertical, I always get that wrong, all the vertical forces to work out this and all that, and the horizontal forces to work out then that. And that would be the process that we will follow for this type of question. Just following the same process, the sum of the forces vertical to solve the one, and the sum of the forces horizontal to solve the other member. So we're really just trying to understand the external force being applied to that joint. We're using that external force and obviously the angle itself to then work out what is the internal forces of that one and that member. So this member and this member. So first thing first, what I'll do is I'll work out what am I trying to solve? What members am I trying to solve? And what do I know? So let's read the example. In the figure above, the truss structure is in equilibrium. Well, that's good, they tell us that. The reactive force at the support L, this is the support, is 10 kilonewtons. So we now understand what the external force onto that joint is, 10 kilonewtons. I have a force. Well, I have a member L, I have a member N, and I have a member M. I know that L is 10 kilonewtons. Determine the force in the members N and M, include a force diagram. Okay, so this is going to be 10 kilonewtons. It would look like it's going upwards. Okay. We need to solve for N and we need to solve for M. Next thing I'm going to do is I'm going to draw my diagram again. So really simple. There, here, here. What do I know about this? This particular force is 10 kilonewtons at that joint. It is a 60-degree angle. What does that tell me? Between N and M, there's 60 degrees. M looks like it's horizontal. So that's perfectly horizontal. That's 60 degrees. What I also know, if I just draw my quick little diagram like that, if it's 60 degrees, that was a bad example of as accurate as it can be. If this is 90, 60 is going to be about there. What that tells me is that my vertical versus my horizontal, my vertical is going to be bigger than my horizontal force. That's just from what I gathered in this particular point here. What I want to do now, I need to solve for N. In the previous example, we resolved, because we knew what that force was, we resolved what its forces were in the vertical position and in the horizontal forces. The horizontal position. We don't know what it is, but we can still use this to solve it to solve what it is. So I'm going to automatically resolve this angled force. If I'm going to find the angled force, I'm going to need to use this somehow. So my equivalent force of N is vertical component. I resolve to vertical component. So itself will be the hypotenuse, but its vertical is going to be the opposite of that angle. So my vertical force is going to be force N vertical, and this is my force of N. This is the opposite. This is the hypotenuse. We know that opposite over hype equals sine theta. where my opposite, which I'm going to now have as my force N vertical, is force N, it's my height, sine theta. So my force N vertical would effectively be the force N sine 60 degrees. I can do the same thing for my horizontal part of that. If that's my angle, this is the adjacent, this is the height, my force of N will be the height, adjacent over hypotenuse equals cos theta. I know that my adjacent is my force N horizontal, so my force N horizontal will be my force N cos theta. Force N cos theta. And it's really simple. I don't know what the force direction will be of that for now, but I do know that my opposite is my vertical component and my adjacent is my horizontal component. And you can see I've already opposite over the hypotenuse is sine 60, and it's that. I'll leave it like that for now. That's normally my step number 3. I resolved that angled load and made it either a vertical or horizontal, so I can solve things. I can solve for it around that joint. Now let's solve for around that joint. First thing I'm going to do is I'm going to do a method of joints around the only joint that I have, which is that one there. What I do then is I go, the sum of my forces vertical, I always start vertical because it's easier, depending obviously on the truss. The sum of the forces vertical equals 0. What that also tells me is the sum of the forces down will equal the sum of my forces up. I redraw my joint. I know I've got an external force applying to that joint straight away. It's 10 kilonewtons going in this direction. I do not know what the force of N is or its equivalent horizontal force. Because I don't know what it is, I assume it isn't tension. And that means my internal force is moving away from the joint. Here's my external force, but my internal force of this member, my force of N vertical, I assume is in tension. Both of my forces are going upwards. So what I have is 0 equals my 10 kilonewtons plus force NV. But I know that that vertical force going upwards, I've assumed it's away from the joint, but my force of N vertical is also actually that. That's how I solve for that. It's 10 plus Fn sine 60 degrees. And I just solve for that. I'll bring this to the other side. Negative 10 equals Fn sine 60. How do I get rid of my sine 60? I divide through. So I have that divided by sine 60 equals the force of that member. And let's see what the calculator says that is. There will be negative 10 divided by sine 60. The force in my member N is negative 11.5 newtons. The sign is negative, therefore it's in compression. If it's in compression, my internal force is moving towards the joint. So it's pushing at that angle towards the joint. What that then tells me now, what that tells me is that if I'm going to do a horizontal force, I'll go method of joint at my joint, but I'll do some, excuse me, force horizontal is 0. The sum of my forces in this direction equals the sum of the forces in that direction. I redraw that joint. If this force is going in that direction, my resultant, my vertical force is going in that direction, and that's my resultant, so it will be moving in this direction. I'll redraw that again up here. That angled force is a resultant of my vertical going in that direction and then traveling in this direction. So my force of N horizontal is going in that direction. We know what that is as well there. But we don't know what M is. And we're trying to find M now. So therefore we assume that M is actually in tension. The force in M, assume it's in tension, therefore its internal force is moving away from the joint. So at the moment I've got one going this way and I've got one going that way, the force of M. So force of M is going in that direction, going in this direction is force N horizontal. Force N horizontal is my force N cos 60 equals force M. We've just solved what force N is. So, and I do not put it now as negative. That is only to tell me which direction it is traveling. I've already, notice here, I have already allocated the direction, so it is just a magnitude. So I put now 11.5 cos 60 traveling in that direction equals force M. 11.5 cos 60, 5.75 newtons. It is positive, therefore it is in tension. So if I go back up here, my force N, the force going down at that angle at 60 degrees is 11.5 newtons in compression, and M is 5.75 newtons in tension. And you see how that made sense now with the 60 degrees of this angle. 60 degree will show how my vertical, my N, this is 11.5, and this is going to be much smaller, so it actually makes sense, 5.75 newtons. My free body diagram will effectively look like this. Bad example when it comes to the angle, but N is 11.5 newtons in compression. M will be, this one is 10. See, that is 10. And this is 5.75. kilonewtons. Be sure to put the correct, I made a mistake there, put newtons only. Were they all in newtons? No, they were kilonewtons. Be really careful with your units, because you can actually get that wrong if you just put newtons instead of kilonewtons. And I made that mistake. Direction is there. This is in compression, and this is in tension, because it's moving away from the joint. And there's your answer for example 4. Really nice and easy. I hope that helps.